Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is continuity. Before giving the definition of continuity, let us try to understand this with an example. Here f of x is equal to 1 if x less than or equal to 0 and 2 if x greater than 0. Let us try to plot this. This is x-axis, this is y equal to f of x this side, and the function value takes 1 if x less than or equal to 0. So this function, this is that particular thing, x less than 0 is this side. Similarly, if the value is 2 here, the value is 2 here if it is greater than 0. This is put a dark circle here because it is less than or equal to there. Here only greater than is there, that is why we are putting a open circle. It means that value is not included. Now what do we observe? We observe that this particular function on this side, on the say left side of the x-axis, it is continuous, and on the right hand side also continuous. But what happens at x equal to 0? At x equal to 0 we see there is a jump in the function. The function was coming like this, then there is a jump in the function here, this is the jump, and then it is going here. The function is not smooth. This function is not smooth. What is smooth function? Smooth can be something like a curve like this. This is a smooth. Without lifting the pen we are able to draw the function like this. But in this particular case we have to lift the pen. We come from here, then we lift the pen here and then move here on this side. So what we observe, this particular function given here is not smooth. It means it is not continuous. This function is not continuous. This function is not continuous at x equal to 0. This is important. Other places it is continuous. This side and this side it is continuous. Let us take another function. Here f of x equal to 1 if x not equal to 0 and f of x equal to 2 if x equal to, we will try to plot this. Let this be x, let this be y, we call it as f of x. The value is 1, so this is 1, here the value is 1, so this is the function, this particular thing. Then the value is 2 if x equal to 0. So at x equal to 0 the value is 2. So this is the point. This is the point 2. This is point 1. So what happens here? Again we see that when x is not equal to 0, when x is, this is the 0 point, when x is not equal to 0 the function is continuous this side as well as continuous this side. But only at x equal to 0 there is a discontinuity in the function. So this function again is not smooth. Is not smooth. It is not continuous. Not continuous. So we now need to explain the definition of continuity. So we'll do that next. Suppose f is a real function on a subset of the real numbers and c be a point on the domain of f, then f is continuous if limit f of x extending towards c is f of c. Means limit we have studied in 11th class, that is if the left hand limit and the right hand limit and the value of function, this is value of function at x equal to c exists, then the function is continuous at x equal to c. We'll see some examples. Let us try to find this. Check the continuity of the function at x equal to 0. So how to proceed this? What is f of 0? At x0, at x equal to 0, f of x is 1. So f of 0 is 1. So we need to find limit x tending towards 0 from plus side or limit extending towards 0. There is no plus minus here. Limit extending towards 0, f of 0, we have to find it. So what we'll do, limit extending towards 0, f of 0 is given here when x is tending towards 0. So we'll take x cube plus 3 or 0 cube plus 3, which is equal to 3. We observe that limit x tending towards 0, f of 0 is not equal to f of 0. F of 0 is 1 here, but limit extending towards 0, f of 0 is 3. Since 3 is not equal to 1, this ensures that the function is not continuous at x equal to 0. We need to discuss the continuity of the function defined by f of x equal to x plus 2 and x minus 2 at x equal to 2. Let us see. Now clearly the function x less than 1, suppose this is a number line, this is 0, when x is less than 1, when x is less than 1 towards this side, the function is clearly continuous. X plus 2 is continuous. When this is f of x, when x less than 1, this particular line on the left side of the number line will ensure that the function is continuous, because x plus 2 will be continuous. It will be defined at all points in the real space. Now let us see what happens at x greater than 1. X greater than 1 will be here. The value will be x minus 2. Again the function will be continuous at all points if x is greater than 1. But the question comes, what happens at x equal to 1? So we can clearly tell this. Case 1 will be when x less than or equal to 1, function is continuous. 2. X greater than 1, function is continuous. But what happens at x equal to 1? That is the point of discussion here. So let us find f of 1 first. F of 1 will be x plus 2, because it is less than or equal to 1. So we put substitute x as 1, so it will be 1 plus 2 equal to 3. Now we find limit x tending towards 1 from the positive side. From the positive side. So that will be x minus 2. So this will be 1 minus 2 equal to minus 1. Again limit x tending towards 1 from the minus side is x plus 2. So this will be 1 plus 2 equal to 3. Now clearly the left hand limit is not equal to right hand limit, equal and not equal to f of 1. So the function is not continuous at x equal to 1 but continuous at all other real values. Now these are some very important axioms which we are going to discuss without any proof. We are not going to give any proof. Every polynomial function is continuous. What is polynomial function? Say f of x equal to x cube plus 2x square plus 3x plus 4. This is a polynomial in x. So this is a continuous function. This is an axiom. We should take it by heart. Now the greatest integer function defined by f of x equal to x is discontinuous at every integral point. What is integral point means? If like xy coordinates are integers, say 2, 0 or 2, 1, so they are the integral points when the coordinates are integers. And what is greatest value function? For example, if we have 3.7, it is the lowest integer value, so this will be 3. Similarly, if it is minus 3.7, it will be minus 4, lowest integer value. Now, what this theorem or axiom says, that the greatest integer function defined by is discontinuous at every integral point. This we should remember it. Let us do algebra of continuous functions. Suppose f and g are two real functions continuous at real number c. Then f plus g is also continuous at x plus c. F minus g is also continuous at x equal to c. F into g is also continuous at x equal to c, and f by g is also continuous at x equal to c, where g should not be equal to 0. Further, we see that the trigonometric functions like sin x, cosx, tanx are also continuous functions. This we should remember. Now, this is a very important theorem. Suppose f and g are real valued functions such that f of g, this is called f of g, is defined at c. If g is continuous at c and if f is continuous at gc, then f of g is continuous at c. What does it mean? Let us take one example. Say we take a function, say sin x square. Sin x square. We want to check whether this function is continuous or not. So what we do, let us say g of x equal to sin x and h of x be x square, so that this function can be written as g of h. So this function sin x square with g of x equal to sin x and h of x equal to x square can be written as g of h. Now what we see, g of x is continuous. Why? Because just now we discussed sin x is continuous. Now what happened to h of x? It is a polynomial function, x square, it is also continuous. Polynomial theorem we just now saw. So what we observe, according to this theorem, if g and h are continuous function, then g of h is continuous. So what happens? What is g of h is? Sin x square. So that's what we wanted to check, whether sin x square is continuous or not. Yes, because from this theorem we see that sin x square is continuous. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.